All right, super excited to have this talk today. And what I would like to cover is kind of how to go, if you want, beyond basic and like how to scale development across large teams. And so, first of all, who am I? I'm Juri Strumpflohner. I'm from Italy. I live in a very northern part in Bolzano, and I'm a Google developer expert in web technologies and Angular. I'm also an academic instructor and Cypress ambassador. These are some of my videos which I have on Egghead. There are more on that link which you see on the slide at the very bottom right. So definitely check those out and like tell me if you like them. Cool. So right now I'm working as a JavaScript and architect and engineering manager for Nowl. Nowl is a consultancy that has been founded by Victor Safkin and Jeff Cross. Both are ex-Angular core team members, which like 3 years ago went outside of the Angular team and founded Nowl. And at Nowl, we try to help the team to kind of learn, grow, and be successful, of course. And now our usual plan or our usual approach is kind of to plan together with the team, help them define priorities, and most details, kind of define the technical constraints as they come along. We also provide, of course, training, on-site workshops and remote workshops, or like talking at conference like this one or in webinars. The preferred approach is kind of be embedded into the team. Like we try to work for a longer period with companies and work alongside their teams because like usually it's not in the workshops where you face the big challenges, but as you go, right? And so when we are on the team, we can actually provide training as the team goes ahead and we can help them tackle difficult problems. So how do you actually scale development? And this is kind of like what we experience while consulting with clients and usually how we approach those problems. Now, I would like to talk about three main things today. Like, first of all, how you can drive and kind of automate good architecture, and also about modern development tools and improved development experience, because like that's actually what makes us productive in the end, and obviously speed. Like the faster things are on our CI pipeline, the better it is for our productivity. And from the tooling perspective, this can be solved mostly with NX. Now, NX is our open source toolkit for monorepos. It's not exclusively just for monorepos. Like, as we will see in the talk today, can also benefit from that even for smaller repositories. But usually that's where NX really shines. And here is the URL and GitHub repository if you want to check that out. Now, if we talk about architecture in general, architecture is quite a broad topic, right? Because like architecture can be about like scaling the application in production. It can be about structuring and modularizing your projects and applications and making sure that you have like good quality code, right? Many times what I've seen, architecture is also about, if you want, folder organization. Now that might sound silly, but it's actually about how to structure a project such that it scales across more teams as your team grows or as more teams come into your organization and into your project. Now, if you take, for instance, a quick look at the Angular style guide, there's actually a principle that deals with folder structuring. So there's the lift principle, which kind of says like it should be easy for you, if you look at your application and you have a component, it should be easy for you to identify and locate that component. And also kind of if you look through the files, you should see like based on the file extension, you should understand like what is in that file. And then also in terms of the structure itself, they kind of or suggest basically to start flat, like as flat as possible, and only introduce nesting levels as you need them, because that keeps the whole structure a bit more lightweight. Now, especially if we talk about folder structure or like flat folder structure in general, there's another style guide which says like folders by features. Now, some of you might have used AngularJS in the days, and in AngularJS actually you had a different approach. Like what you did there is kind of have like structuring according to the types. So you had like controller folders, model folders, and view folders. Over time, most of the frameworks have seen that this is not the way how things scale, because like it's kind of difficult to like navigate all across all those folders, but rather to kind of try to encapsulate problems inside a folder. Like one feature is inside a folder and kind of can then use functionality from other features. So this, for instance, might be one of the examples which I've taken from Twitter. You can see here there's even like kind of a structure about admins, and maybe there's another section of the project. And then you have like the coupons, the courses, which are all kind of features, right? Reporting, sales, and so on. So if you have such a structure, what might be a potential issue? Let me talk about a couple of them. Like the first one is actually the feature boundaries. If you take again a closer look at the courses part, you can see there we have like the components folder, we have the containers folder. There's even some guards and models further down, which we don't see in a screenshot. But it is immediately hard to see what is actually intended to be public and what is intended to be private just inside that courses folder. And so actually that's the main point here. Like the problem is you don't really see what you can use from a feature because you might want to grab into that feature and use, for instance, what you have here, the course item component, because it might be useful for your own feature development, which like is in a different section of the project. And this is kind of that, if you want, monolithic part when you, for instance, use the Angular CLI nowadays. You have basically the structuring according to the folders, which are the boundaries for your features. Now, NX is a different approach. Like the building blocks there are actually apps and libraries. And so here you can see actually the graphical visualization of our previous application, which is here the Angular, Angular CLI project setup with an NX workspace. And you can see now they are being split up basically into a more thin application layer at the very top basically here. And then a lot of well-defined libraries, and I call them here workspace libraries. And the reason is that when people see the word libraries, they usually always immediately think about something that needs to be publishable, really general purpose. That's actually not necessarily the case. Like in an NX workspace, those libraries can also just be there in that same workspace without ever being shared outside. And they can just be referenced by applications that live also in that workspace. You obviously have the chance or the possibility to publish them also outside, but that's usually not the default setup. And so you can see basically the apps at the very top, and then there are the libraries. And our suggestion here is usually to have like 90% more or less of the code in the libraries, because that basically gives you a lot of possibilities as you go, and especially in terms of scaling. And in fact, like what you could do is you could actually split up your applications. You might start with a single one, but actually you might identify that it really is kind of split into a more public-facing part of the project and a more administrative part, which is like more the back office if you want. And so in this case, you can see now the public one like just references the libraries it actually needs. And similarly, the admin part just references its own libraries. And you can also now see that how you can then deploy these in a different manner. Because like the applications in NX are really just, if you want, deployables. Like they are the ones that reference the libraries, you build them, and you get basically the output in the dist folder, which you then like just copy over into the production server for hosting. And now having two different applications, you can also scale them differently. Like you might scale the public one a lot more because like you might have like majority of users landing on that part, while the administrative part is more like a couple of people that are using it for kind of managing the whole application. So how does an NX library structure look like? In the screenshot here, you can see like the example, which is based on the one we have already seen. So basically you have that libs folder, and then you have a different kind of folders for each of those libraries. And each library has a source folder, and then inside there, you can actually have a similar structure, even the identical structure which you had in a folder inside Angular CLI project. The only difference here is, as you can already see, is that you export something in that index.ts. Like the index.ts for you here is really like your public API. And so for instance, if you want to use something outside your feature, you actually have to export it explicitly in that index.ts file. And for instance, here I'm exporting a service, and so such that it can then be consumed by some other part. The cool part here is also that if you use that, for instance, in another application or in another library, that import path is actually like kind of, if you want, like well-defined path. Like you see that add course platform, which is the name usually of your NX workspace. And then you have like /store/courses, which kind of the path into the libraries part. But you can see like NX already sets up the TypeScript path mapping when you generate new libraries. And this makes it easy to consume that in a nicely fashion without having to basically have relative imports. So in general, like if you take a look here, libraries represent a much stronger boundary compared to folders, especially because like you have to explicitly think, what is my API? What do I want to export? And what do I want to have like private within my feature boundary? Another part is obviously visualizing dependencies, especially if you start small and then the thing grows. Different teams might work at the same time on a project or in that monorepo. And so what you want to have and what is really powerful is you can visualize the whole project. And so in this case here, this is an example of a real project, which we use basically. You can see the link at the very bottom here. And if you launch NX depth graph, it will live basically calculate this graph based on the current state of your source code. So this is not like the usual documentation diagrams, which are out of date in the moment you create them, but these are basically calculated out of your source code. And they help you a lot to reason what basically depends on what part and like whether those dependencies are actually legit. And that actually brings me also to the next part in terms of restricting access. Because sometimes if you have, for instance, this feature structure here, which we have seen at the very beginning, what actually prevents someone from just like going in there, using that course item and use it basically within their own feature? That's actually kind of easy because like they can just like import it with a relative import and nothing actually prevents them from doing that. Now in NX, there is actually a mechanism that helps you structure that. And that's the so-called kind of labeling or tagging. And so here, for instance, you can see that type : app. And this is actually just like a string which you attach to like the applications and libraries. And usually the recommendation is, however, to kind of have that separation, like that you have like a prefix, colon, and then whatever you want to place after that. And so for instance, in this example here, I'm having that type application, which I'm attaching to the public and the admin part of my structure here. Then I have basically the courses libraries, and I'm adding the type feature there. And finally, I'm having more the kind of utility libraries, which are the shared and core, which is more my, if you want, infrastructure part of the whole project. An next part can also be then to actually add some more like functionality related tags if you want. So in this case, I'm having like a scope store because like some libraries might actually just be used by the public facing store application, while others might be used by the whole admin part. And similarly also for my infrastructural part, I can attach their scope shared and scope core, for instance. So the whole point of defining these is that once I have defined those tags, I can actually start defining rules. And the rules can look, for instance, as follows. I can say like a type application can always only depend on something that has the label type feature or type utility, because that's how you expect the references to be. And further down here in the slide, you can see that this, for instance, would prevent me to have a reference from one application to the other type application. Similarly, I can say, for instance, a type utility should only be able to depend on a type utility. The reason here is that utility libraries are usually the very like last parts in my whole graph. They just like provide some general purpose utility parts. And again, here down here, you can see I don't want to have like libraries which are of type utility that might depend on a feature, right? Usually the dependency should be actually vice versa. So the feature depends on the actual utility library. And then also the scope, like the scope can be very similar. So in this case, I say like the scope store can only depend on other libraries that have the scope store, or obviously scope share, because like it might be shared between store and the admin part in our example, and scope core, because like those are my infrastructure parts which I might need, for instance, authentication, logging, whatever I have in my project. And so this is basically to kind of segment my workspace, because like I might not want someone to basically reach into the admin part from my public facing library. Now, the whole point here is that once you do that, you get actually an error usually on your CI pipeline. And at that point, you can actually then look into it and verify whether this is a legit dependency and then decide how to proceed. Either extract those parts which are shared into, again, a shared library, add the scope shared, and then it would work again, or just not depend on it and like kind of refactor it. And you define those rules, like here, those are basically represented in a graphical way, of course, for a better understanding, but you define them in your TS-lint JSON, where there is a specific rule tag, which is NX enforce module boundaries, where you can define them in the following fashion here. Another part is then feature reusability. And that obviously makes a lot of sense, because like you have already seen the structure about apps and libraries, and we even like split them up into two applications. So in this case, we have just two apps which like reference those libraries, but you could go actually a step further and have like also a React application in there, or even backend applications, such as here a Nest app, Nest.js app, or just a plain Node Express application. And they can obviously then share even libraries between like the backend and the front end, or even like between React and Angular. And this can then actually get really powerful. Finally, there's architecture automation. Like the whole title here for that section of my talk was kind of drive good architecture, but also automate architecture. Like that's the best way you can actually guarantee it's actually respected. And if you think about the whole linting part is already kind of an automation, because like you add restrictions on what can depend on what other part. And so with that, you already have that automated in your CI pipeline, for instance. Another really good part about automation is the whole workspace schematics. Now, as an Angular user, NX gives you already a lot, or like in general, like as an NX user, it gives you a lot of schematics already out of the box. And so we have it, of course, for Angular projects, like for generating components or generating new applications and libraries, but also for React, for Storybook, for RxJS, even like for web components if you want. Same holds then also for backend parts or the setup for Prettier and TS-Lint. The power, however, really is in the workspace schematics, because like that allows you to create such automations, such basic schematics for your own workspace. And that obviously means they can be tailored to your business needs, because like, for instance, how NX generates the library might not be enough, because like for your organization, you also need to kind of reference the common style guide library, because like that's what you should be using within your project. And so what you can do is, in a more advanced scenario, you can actually generate such a workspace schematic, and you can do that with the command you can see on the slide here. And then inside there, actually, you can code that schematic by reusing other schematics. For instance, you can invoke the NX library schematic and then add another file, generate new Angular components, whatever. Obviously, this allows you then basically to optimize the things for your business needs. And that obviously also increases developer velocity, because like they can just like invoke that custom command they have, and then they have basically all already set up what they need. And obviously, it also guarantees compliance, because like then in that case, basically the generated structure already respects your internal guidelines. And once you have that schematic, so in my case, basically we named that my schematic, then you can just like invoke them with an NX workspace schematic, and you give it a name and obviously the options which the schematic takes. So the second part is about modern tools, and this usually goes with improved developer experience. And so just as a reference, the NX architecture is mostly like the following picture here. So you have the dev kit at the very bottom there, which provides the whole mechanism for running those schematics, those automations. Then there's the Angular CLI on top, or the novel Tau CLI, which is kind of an equivalent to run commands against those basic schematics. And then there's the novel workspace on top of that, which provides the whole parts about the dependency tree, dependency graph, which we have seen, and those kind of automations. And then we have a set of core plugins, or also like community plugins. So this is the point where kind of you can actually come in and provide your own extensions. For instance, we have plugins for Vue. We have plugins even for like generating new folder structures according to the domain-driven development model, and a lot more interesting things are coming along. And then when we go a step further in terms of automated testing and quality control, we also try to use or set you up with modern tools. For instance, for unit testing, we by default generate Jest tests, because we kind of think that those provide a better developer economics in general. And also for end-to-end testing, we default to Cypress. Obviously, you can always choose to go with Karma or Protractor when you generate new libraries or applications. That's perfectly fine. And so in the end, like when you generate a new application, you will see you automatically get an end-to-end test generated and set up for that specific application. So we already kind of pre-configure your workspace with some best practices that help you proceed basically in a good way. There are also some very interesting combinations. For instance, you can have a UI library, and that's actually a very common thing, to basically have a library that has your internal design style guide components, which you might use within your organization. So you can actually generate that library, generate components, and then generate a storybook setup for that specific library. And this can all be done with schematics NX provides you. And you can even then on top of that generate Cypress tests, which will just like run against your specific storybook stories. And so it's a very easy and kind of modern way if you want to test components in Cypress. Finally, also about linting and code formatting. It might not seem that important, but it actually is a lot important, because like you don't or you shouldn't in general worry or have to worry about the formatting of your code, but you still should have something in place, because like otherwise you might run into strange merge conflicts, which again slows down your team. And so NX comes already with pre-configured prettier setup. And in terms of linting, we also now support ESLint for Angular projects. ESLint is going to be deprecated by the end of the year. And so we already provided some starting support for ESLint, and we are hardly working on improving that in the coming weeks. Finally, also tool integrations, of course, and into the IDE. So for instance, we have integrations, or NX provides you some integrations with Visual Studio Code and WebStorm. You can, for instance, like just run the Jest test if you have some of the Jest runner plugins installed. So they will automatically pick up inside your monorepo the actual configuration for Jest and then run it. Also, recently we added some interesting combination together with NX Cloud. So you can actually have a GitHub bot installed, basically that kind of lists you all the commands that have been run in that pipeline. And you can then click on it and you can see then you jump basically onto a page within NX Cloud, which filters out the actual things you want to have a look at. For instance, just like the failed projects, and then you see the actual log below it, without having to actually go into the CI logs and like scroll through some weird and hardly understandable logs and search for what it actually went wrong. And so if you want to know more, we actually just published an article a couple of weeks ago, which talks about modern Angular and how we envision that. And we will continue to work on that as we go ahead. Cool. And so to the last topic, that is about speed. And that's kind of a topic which I really like, because like we all don't really want to wait until like the build finishes or the test run finishes. And especially if you have kind of a monorepo scenario, that might get even worse, right? And so at now we actually believe a lot into the whole monorepo story, because like we have seen that helps large organizations deliver their code in a lot faster way. And so the main rule there is basically in a monorepo, you can envision that as one Git repository where you have all your front and back end code. Now, that's usually not always the case. Like you might just have like some front end projects, not even back end projects maybe, but the ideal case would be if you have them mixed in. So you might ask, like, what is actually wrong with multi-repos? So why should I use a monorepo, or why cannot I just proceed with a multi-repo? Well, if you take a look at this structure, for instance, which you have seen before, so we have like a couple of Angular applications, some React applications, backend applications as well, which all use like those libraries. And like the code below here would be the shared code, which in a multi-repo would have to live as independent NPM packages. So you would have to set up some kind of internal artifactory or NPM registry, publish it there, but you also have to version it. Now, if your applications depend on all those parts, you have to be very precise with the versioning and with backwards compatibility, as well as with potential conflicts, right? Because like in theory, every library here, for instance, could have its own Angular React version or whatever framework you're using, its own TypeScript version, its own Jest, Karma, and Jasmine version. And so not always that's guaranteed to be backwards or compatible between each other, right? Like you might have like some library using Angular 8 and another application actually already having been upgraded to Angular 10. And so also like if you just think for a moment at an organizational level for yourself, like how difficult is it for you to upgrade to the latest Angular version? Like not just the application you're currently working on, but like at a scale of the entire enterprise, like within your organization basically. How long does it take, for instance, to distribute security patches? Like some security problem just leaked and you have to provide a patch to like all the applications you have in your organization. Or how difficult is it if you need to do some cross-cutting refactoring? For instance, you have some shared library and that library is used in many projects and you want to do a refactoring of the API. And that obviously means like changing API. So how difficult would that be? Or also corporate design systems, which is like very famous part. Because like that's used in a very lot of realities. So in general, a monorepo you have the situation, or in an X case, for instance, of a monorepo, you have just one version of Angular, you have one version of TypeScript, you have one version of Jest, and the reason for that is because you just have one version of the node modules folder. And so if you upgrade, for instance, Angular, you upgrade the entire monorepo. So what you can do is you can just like create a new feature branch, run the migrations for upgrading, run all the test cases, run the end-to-end test cases, fix whatever needs to be fixed, and then merge it back in without actually disturbing the team. And at that point, all of them have been upgraded. But obviously, you don't want to build, test, lint everything every time, right? Because like, especially in a monorepo, that might not scale. The point with NX is that NX actually knows what you're building, and that's how NX can help you actually overcome some of those issues you might face in a monorepo. So we have seen the dependency graph, and that's actually what NX also has behind the scenes and what it can use for calculating things. For instance, you can run an NX affected dependency graph. And so in this case here, you can see those red parts have been detected by NX that they have been actually modified. What NX does is, for instance, in your PR, which you create, it runs through the Git commit history, and it identifies the project you actually touched. And as a result, it can only run the test, the build, the linting, whatever you need to run on those 3 projects. And so you can exclude all of the others, which you can see in this graph. And you can imagine that this already helps a lot in scaling your CI runs. And so you have those affected commands for testing, building, also for your custom targets, which you might define in the AngularJSON file. Another thing I'm very excited about is the recent computational cache, which we have introduced. And this is kind of an addition to, if you want, affected commands, or in general, like when you run a command, NX basically takes the source code which the command has ran against, a couple of environment variables, and then it stores the actual output in a cache. Now, the next time you run it again, it verifies whether the source code, the command, and the environment variables match something from the cache. And if it does, it just like restores that cache onto your console output. And that's not just like for actual like writing the log out, but also for like recreating the bundles and files which might have been produced. This gets even a step further if you have NX Cloud. Like with NX Cloud, the local cache in the computation cache which you have in NX is just for your own. But with NX Cloud, you can actually distribute it to your entire team. And so here, for instance, you can actually upload it, like when NX doesn't find it locally, it uploads it to NX Cloud, and so your teammate can actually download it as well. And this happens obviously completely automatically. So if I run tests on a project and my teammate has the same setup, the same source code, it won't run actually the test, but just gets the output immediately. That speeds up things a lot. And obviously, if you wire in the CI server again, that gets even faster. And so this is especially useful if you have environments like this, right? Where you have like, for instance, here in a month, the average like PRs that have been merged in are 400. And you have a constant situation where you have like 45 merge requests which need to get into master. And so in such environments, having a fast CI build is actually crucial for getting things started. And so to play around with NX, you just like run npx create NX workspace, you give it like the workspace name, and then you run through a couple of questions which you ask, like giving it the name of the store, choosing the preset, having like a couple of styling options which you might use. And also here in this case, you can choose for ESLint. And also for NX Cloud, which we have just talked about, you can actually just opt in. NX Cloud is a commercial plugin for NX. However, it provides you with 5 free hours each month. And so that's perfectly fine to just get started, to try it out, to play around with it. And at the maximum, we save 5 hours each month for you. And so in the end, you will get like this workspace where you can see like the apps and libs and start playing around with it. So thanks a lot for your attention. And obviously, if you have questions, definitely reach out to me on Twitter or connect with me there. I'm happy to answer them and talk to you. Thanks.